Hello, this is Isaac Edwards and Noah Wilford's math final for Intro to Mathematics. Today we're going to be talking about the history of mathematics in China. We got a few topics and questions we're going to discuss. We got 8 of them. Let's start off with the first one. I mean, you got to go all the way back to either the first person to understand or teach like math in China. We couldn't really pin it to one human, but we did find an old text in 1000 BC. Sorry, it's called the Yi Ching.
I Ching.
Yeah, and it's one of the oldest texts. So yeah,
it's a collection of divination texts, which is like religious texts, and it's supposedly written by this guy named Fu Shi, who does not exist. He is credited with creating humanity.
Yeah,
which is quite a big feat for a mathematician.
Yes.
I didn't know they could do that. It has a lot to say about hexagrams, and people think that it contains kind of the beginnings of binary numbers. And it's about this time. This is during the Shang period, which is like 1600 to like 1050 BC.
Yep.
Where we see people in China kind of start to come out with arithmetic and negative numbers and counting rods and things like that. We see really early on forms of decimal multiplication tables, which is quite interesting here.
Yeah. And that's all laid out in just these texts.
So
far. All right, and then second we got what was like the main instrument of use for math in China, and we got the abacus.
I
baby.
love the abacus. You ever see Penguins of Madagascar? The one dude's got the abacus. Yeah.
So it's just like made it out of bamboo sticks, which shout out the pandas. And they squares and with checkerboards. So each rod represents one digit, and each multiple digit number laid out using a numeral system on a base of 10. So that was cool. And they were able to use decimal points. They were able to figure that out with an abacus.
Yeah, lots for trade and for bartering and things like that.
And then, so the third...
And that kind of goes into our third question.
Yeah.
Sorry, didn't mean to interrupt you.
So it's like, what does math, like, how has it progressed over the years? We know, like, technology has helped math in any which way, but... So it's heavily based in China around architecture, production, space travel, they're going to space, and economy.
Yeah.
As we know, China is one of the biggest growing economies in the world. So, I mean, they've been able to use all the ancient stuff and just make
mathematics. It's devoted nowadays a lot more into engineering and things like that. The abacus has we're a bit beyond the abacus, I think.
Calculators now. So
I thought this was really interesting. So question 4 was, how did each dynasty react to math and academia? Most of them were very supportive because it was considered like a minimum for learning is knowing your mathematics. But during the Qin dynasty, was this 3 years? It was 213 to 210 BC. I think that's this particular event. I think the actual dynasty lasted a little while.
Okay,
we can give it a Google.
But
it lasted about 800 years. The dynasty, but around 213 BC, they actually really hunker down on scholars, and so they start burning books and burying scholars alive to try and really hone in the information to be only things in support of the Qin dynasty.
Yeah.
So most of the math at the time was geometry used for building statues and shrines.
Yeah, to the Emperor Qin Shi
Huang.
Huang. That's Huang with an H. Okay.
It was also at this time that the Great Wall of China is started.
Yeah. But they were just building like shrines to him, and that's the only way they were using like geometry and stuff was just to like please the emperor. So.
Yeah, and a little bit more on I guess killing people. The military uses of math in ancient China. So Sun Tzu with the Art of War talks about how the Chinese managed to hide rows of soldiers, like their soldiers' numbers, using Chinese remainder theorem.
Yep.
And so people say that the way it works is you have soldiers line up in rows of 5, and you end up with 3 soldiers in the last row, and then you have them reform in rows of 8, which leaves 7 in the last row,
Yeah.
and then rows of 9, which leaves 2. At no point have you counted all your soldiers, but you now have enough information to determine the total number without having to state an explicit count that an enemy could intercept.
Mm-hmm. Another thing for military was, constructing like weapons. So they had like catapults, and you need math to use catapults. You need to know like angles and dimensions and stuff, so you can catapult a big rock. You need to know the weight of the rock, and you got to throw it over. And that's like just straight math. That's like
Yeah, it's physics.
just physics, math. So yeah.
It is interesting though. One of our questions here is what kind of mathematics did the Chinese devote themselves to studying? A lot of it early on is a lot of geometry,
Yes.
a lot of architectural things. Also see a lot of finer definitions on like the meaning of lines and the meaning of points that come kind of around the same time as Euclid and Plato, who discovered the same thing in Greece. So lots of conversation about like linear planes and things like that, which become very useful for Chinese architecture as they start to make more complex shapes.
Yeah. I think we can't not talk about the Great Wall.
Yeah, the architecture and geometry becomes really important with that too.
For that, I mean...
especially because it's built over a mountain range, right? It's already built over what's called a natural wall.
Yeah.
And so there's lots of calculation on how do we get these slopes in with bricks, which are obviously rectangular. They're not curved.
Yes. What length does a brick need to fit this point, like in between two mountains? So yeah.
You ever been Great Wall of China?
I haven't been out of the country, so
I have,
you?
but not China. No.
No. China would be sick, but just to explore maybe. I don't know.
Sure.
And then 8, how did Chinese mathematics influence other parts in the world, and how was China influenced by other parts of the world? So they made up the negative numbers. That's what I found. Like they just created that and shared that, and then it was found out by Zhang Zhizhang. There we go. Yeah. Names are hard. And then so they created that. Also, algorithms. We forgot to say, but they made their own type of Pythagorean theorem. It's called the Gogu theorem.
I think it's Guju.
The Guju, and it's focused on astronomical calculations.
And it's really interesting too. It doesn't use the triangle as a shape. It almost describes the relationship of 4 different triangles inside of a square.
Yeah.
So Pythagorean theorem deals simply with right triangles. This deals with much more complex shapes.
Yeah.
But it's pretty similar.
So yeah. I don't know where that theorem went. I wonder, is it still used?
Well, the theorem itself is c squared equals a squared plus b squared, which is just the same as Pythagorean theorem.
So yeah. I wonder, because I wonder if they people shared just the Pythagorean theorem with them, and they're like, yeah, you can just do it this way, and they're like, oh, okay, that's simple.
Yeah, I mean, as we find out the same things over time, we kind of.
So yeah, that was our final project. Thanks for listening.